Hey going guys, Curtis from Cutting Edge Engineering. Today's job we're going to be machining up the new nut for our EX1200 cylinder rod and re-threading the rod to suit our new nut. So if you missed part one where we had to gouge the C's nut off the rod, we'll leave a link in the description below. So our material has arrived and so has our upgraded tooling from our supplier. So our piece of material is a piece of 4140 centerless ground rod. It is 8 inches in diameter and 150 mil tall. I did try to buy this in a hollow bar to save a little bit of work, but the sizing I needed is not available. So we're just going to have to start with a piece of solid bar. And at the moment, this piece of material weighs 38.4 kilo. We have got a lot of work to do to it, boring it out and turning the OD. So it will be interesting to see what we're left with. First thing I'm going to do is get it set up in the lathe. So the first thing I'm going to work on is the ID of the nut. So I need to drill and bore it to size. But before I can do that, I'm going to face the end of the material and put a center in it so I can start the drill. So what I need to do now is drill a hole through the piece of the material, and to do that we're going to be using some of our upgraded tooling. So let's show you what we got. So what we got was 2 new boring bars to do internal threading, and we also got our new drill, which I'm very excited to use.
Ooh.
That goes with this. So what I ended up getting was a 90mm spade drill. It is a BPK brand made in Korea. What makes up the drill are 4 parts. There is a drill body, there is a collar, there is then the drill head and the insert. So one of the reasons why I decided to upgrade to a spade style drill is with this drill body and this head, I have got a range from 90 to 101 mil. But not only that, the inserts you can buy, they can go up in size in 0.1 of a mil increments. So you can drill over 100 different size holes with this one drill body and head. Another great feature of these drills is you can buy extensions that you can bolt onto the body to then make the drill as long as you want. And another one of the reasons why I've gone to a spade drill is I have got many different sizes of very large diameter twist drills. They are all second hand to me. I've never bought any of them new. And after time, after they get reground, they do lose their hardness and they're just not keeping an edge. And for the price of 2 twist drills, about 75 mil in diameter, was actually dearer than me buying this entire setup. Providing I don't damage the drill head or the body, all I need to do is replace the insert. And you may have seen me using Cruz drills. They are fantastic for drilling induction hardened material. and you can get different geometry drilling inserts for them for doing different sorts of jobs. But the Cruz drills only come at what size you buy. You cannot put a larger insert in them. We have been thinking about doing a comparison video of the 3 different styles of drills. It's not something that we would normally do, so if there's enough interest in it, we'll make a video. So let us know in the comments below. So because we are moving over to insert drills, they do require through coolant. Otherwise you do burn out the tips and it does get very expensive. I have been using a Morse taper to ER50 collet chuck in order to use my Cruz drills, but that's just not going to work long term. So I've also upgraded a holder that goes in the tailstock so I can feed coolant through the drills. I've been looking for one like this for quite a while. I didn't find anything that I was willing to invest in, so I did put my tooling supplier on the hunt to try and find me what I wanted. He did find this in Taiwan at a company called Precise. So a lady, Miss Sherry, helped him out and they got me the holder that I wanted. Thanks Miss Sherry and Arthur from Live Tools. So what we got was a Morse Taper 5 side lock holder that you can feed coolant down through your drills. This one has reduction sleeves so you can put different size side lock drills into it without having 5 different holders. It'll be interesting to see how this performs. And something else I did do, I did put a manifold up on the coolant system so I could feed coolant through a flexible hose down through the drills. Doing that would mean the hose has flexibility and it would move with the tool, but that's not really working to plan. I believe because I'm using air fittings, they are quite restrictive, so I'm just going to have to change that later on. But just for now, we're just going to use a lock line straight into the top of the drill. Righto, so pretty happy with those results. That only took about 12 minutes to punch a 90mm hole through a 150mm thick of 4140. So the surface finish in there is actually really good. It's very smooth and it's not scratched. It was a little bit chattery and a lot of vibration in the beginning trying to get the insert into the job, but after it was in there, it just ate it. After using the drill a little bit more, I would probably be able to dial in the speed and the feed rates in order to maybe make it a little bit better. I was being a little bit conservative because I don't want to damage it, and it is the first time I've used it, so very happy with that. Now that we've successfully drilled that to 90mm, we're going to bore it out to its finished ID. So I've got the ID bored to size. I'm just going to skim the OD down to our final dimension. Then I have a step to machine into this end of the nut, and that is what's going to go underneath the piston. And then we can thread it. So now it's time to do the threading. We're going to be using one of our new boring bars. So I ended up getting 2 bars the same diameter and the same length. These are 40mm in diameter, 300mm long. One is more suited for finer thread pitches, and I'll be using a 3mm full form insert. So I'm starting to run into a little bit of chatter as I'm getting to the final dimensions of the thread. What I'm going to do is slow down the RPM and take some spring passes just to try and eliminate that chatter. So that thread looks really good in there. We're perfectly on size, so I'm not going to go any further with it. What I'm going to do is flip it in the machine so I can start doing the other side. Now that it's flipped, all I need to do is turn the OD to size, face it to length, and machine in a relief in the bottom of the nut. Matched in spot on. Righto guys, so I've got all the turning done on the nut. What we're going to do now is take it out of the lathe and go set it up in the milling machine. Righto, so I've got it set up in the milling machine now. What I'm going to do is mill 6 equal sides on the nut, and that is so the spanner that goes on the ram bench that torques the nut up to the required spec will fit over the nut. To do that, we're going to be using a super indexer. It has a 6-position plate in the back of it, so I can turn it 6 times equally and get a perfect hexagon. So I'm going to mill each edge to within half a mil of its finished size. Once I've got all the material roughed out, I'm then going to come in with a fly cutter just to clean up the surfaces. So those surfaces cleaned up really nicely. There's just one more thing that I need to do, and that is drill and tap a hole through the side of one of those flat surfaces, and that will be for an M20 grub screw, which will be used to lock the nut from undoing itself. Righto guys, so that is our nut 100% completed. I'm really happy with how that came out. Everything looks really good. And after all of the machining, we actually removed half of the weight from what we started with. It is now 16.2 kilo. Now that the nut's done, we're gonna get the rods set back up in the lathe. So there was some common questions from viewers in the last video we thought we would answer. The reason I gouged the nut off the rod and not machine it off in the lathe is the piston was actually covering about 8 to 10 mil of the nut. So being able to get underneath the piston to completely machine it out would have been quite difficult. Gouging off the nut only took about 40 minutes, and that includes setting up the gouger and doing the job. Setting it up in a machine to do that could take a couple of hours. So gouging was by far the fastest method. Probably the most common question was, why don't I just machine off the damaged thread, put a new layer of weld on there and machine it back to size? That is something you could do, but there are a few reasons why I wouldn't do it. There is no repair procedure or salvage procedure to do that to a cylinder rod, because the material you are putting back on the rod is nowhere near the same tensile as the parent material. Even if you did get it to match up, it would still need to be heat treated to avoid the heat affected zone, which could potentially lead to hard spots and cracking. Even though way we weld eyes onto cylinder rods, it is a completely different application and under very different stresses. And there are other workshops and people that will do a weld repair on a threaded area of a cylinder rod. I have seen far too many of those come through my workshop that have failed. It's either completely stripped the thread off the rod or the nut has seized onto the rod because they used material that was too soft to handle the torque being applied to it. So even though that may be an option, I'm not going to risk the customer's very expensive rod, because if that thread is to fail, it is going to destroy another $3,000 nut and potentially the rod, and that would be at my cost. And as I said in the first video, these components are a very high turnover item. Because of the environment they work in, they are easily damaged, so I'm not at all concerned that it has a custom nut on it or a custom thread on the rod, because it probably won't be too long and this will be back here having a new rod put on it. I do need to remove that one a bit more. Take this very steady. Righto guys, so that's this job successfully completed. We saved the cylinder rod for our customer, and the entire job only came in at about half the price of a genuine Hitachi nut. So we're going to get this one on its way back to our customer, although I'm probably going to see it again in a couple of months' time for me to do a re-rod on this. Thanks for watching. For our EX1200 rod. Oh, fuck.
Yeah.
Right. Fuck.
Start again.
Right. So as I said in the first video, oh fuck. Oh fuck me. Fuck me. Oh fuck. It has to be said in a way.
Not that way.
Are you ready?
Yep.
So so our material has arrived, and so is how So our material has arrived, and so is how.
What the?
Righto guys, so that's this. Righto guys, fuck, this sounds worse every time. The more I say it, it sounds like gibberish.
That's because it is.
English good. Miss speak the good England. Thanks for watching.
Now what?
I'm going to take it out with a forklift now. I thought I'd do something different.
Yeah, Mentos.
We'll save it
Oh,
once
look,
or
look,
twice.
look, look.
Oh, there's more Mentos in there.
Yeah. Is it going to be a pink one?
Come on, pink one. Ah, fuck. Ah, pink one.
Yay.
Throwovers are one of those things you're going to get when it comes to 4140 and light cuts. It's very difficult to get that even, everything happy. If you're a machinist and say you've never had one, you're full of shit. Let me just get my ruler.
That's so silly.
Oh, you're silly.
You silly duffer.
You silly Billy.
Tom.
It's alright, it's alright. The day's finished. We get to go home.